money for you. Now, next step is to select the variables. Okay? We click on variables. And now, our dependent variable is categorical. As we see, it has two different categories: good, bad. Okay.
Or you can show the appropriate.
Show
appropriate. Yes. Show appropriate variable only. Yes, you can. You can select it.
In case you are not sure with what kind of variable you're dealing with, so you can ask the software to show you the appropriate variables.
Only here they can show the category continuous data. Only this column they can show the category data. Okay.
So from our 14 from our 14 predictors, okay. No, this is good.
Oh, these are few. Sorry.
Yeah. So from our 14 predictors, we have 11 of them being categorical, and 3 of them being continuous. Now, make sure you select the right variable in the right place, okay? Because we don't have any continuous dependent variable. So I wouldn't want you to be selecting continuous as your dependent variable. Okay? That's why from the beginning of this course, we emphasize on knowing your data, knowing the data type that you're dealing with. Okay? So, as we move along, now we are going to check our sample to decide on the training and the testing sample. Alright?
Yeah. Even here, you can select your case, right? Sometimes all of these, you have people living in north of Vietnam or south of Vietnam, or you can select people in different countries. You want to analysis separate, okay?
Yeah.
If you want to do the cultural comparison, okay? You can analyze it by each country, and then the whole data doesn't matter.
Let's say you have a very big data set that is made of maybe 5, 6, 10, 20 countries, and probably you don't want to analyze all of them all together, or maybe you want to select just 2 or 3 countries to compare, or maybe you have 10 countries but you just want to compare 2 of them. So you go there, you select your cases to select which one you want to use. Okay? But if you're using the whole sample, this is of no use to you. So we decide on the training and the testing sample. So we set it up to 70%. Okay? And our options, we are going to select the options. We select the Manhattan City block. Okay? Probably for those of you who already did a bit of statistics, basic statistics before.
City block.
Okay? Or those of you who didn't do that, maybe you want to review your designs of experiment.
European or European square, okay? Last week I introduced what is European from the tree. Or European square. City blocks does mean Manhattan distance. Okay?
So we are going to set the cross-validation parameters. Okay? So normally we have to apply the cross-validation for the model selection. Okay? So normally I believe the default is 5 for the maximum, but actually we set the maximum to 10. Okay? We don't have to worry about the memory usage because this is something out of our control. Okay? This is related to the computer. We don't have to set it. So next we click on OK. And a window pops up where we are informed of all the criteria we selected. Okay, our dependent variable is credit standing. the independent variable, they are all listed for us. And the sample size is divided between the training and testing and overall. So overall we have 424 cases, right? And we have 296 as our training and 120 as our testing. Now, nearest neighbor result, number of nearest neighbors, 10. Distance measured as city block, okay? And yes, we selected input standardization, averaging uniform, and the cross-validation percentage is at 69.25%.
Why? Because the cross-validation is not good enough. You have better higher than 75% for the better. Why? Because you use too many predictors, noisy, too much. You know? Manhattan distance not only consider point to point, the nearest step, they also consider the other attributes. Okay? They also consider the other feature. Okay? 曼哈顿距离跟欧式距离最大的差别，它会考量你其他相关特征的向量。They not only consider one attribute distance, they also consider the other vector attribute. Okay? They still listen that kind of noisy. So your cross validation is not so good. Okay? So you have better build out something like a regression will choose important predictor. Your cross validation will be good enough. Something like your reliability. Yeah, go ahead.
Okay, so now for the testing data set, we are going to check the prediction and accuracy. So we click on predictions. Okay, we're gonna check them one by one. Okay, we see the predictions. It will show you all the correctly and incorrectly classified cases, okay? Just as much as you can do it for the training data set as well. If you do it for the training, you can see the training classification where they were correct or incorrect. And we can do it for the whole sample, okay? So we do it overall. Now, we can also check the summary. If you check the summary, it will show you the number of dependent variable, okay, the number of independent variable, the number of nearest neighbor, the input standardization, and the averaging, which actually you don't really need to look for because you already have it in that window. It's already showing up here. So you don't need to go for it again if there's nothing specific you're looking for. So next we can also see the confusion matrix, the same way we proceeded earlier. You check the descriptive statistics, and it will show you the confusion matrix, where you can see the classification and misclassifications, where you were accurate, where you predicted well, or where you didn't predict well. Do you see? Oh. So, for the good, we predicted 74 would be good. However, 53 of them were good and 21 were bad. And for the bad one, we predicted 54 would be bad. However, 38 were really bad and 16 of them were good. Okay? So the confusion matrix shows you how many correct and incorrect misclassification you had for each group. Understood? Remember, the confusion matrix is one of the primary or main results actually you are looking for. Although you can check the predictions for each sample, training, testing, or overall, one by one. However, the confusion matrix puts it in number for you. You can see how many good classification you had, how many bad, how many wrong, and how many were right. Okay? So this is why the confusion matrix usually is one important result you're looking for in any classification problem. Nearest neighbor with the optimal value of k being 10. Okay? We check the histogram. From the histogram, we can see the percentages in terms of histogram. We can also see the cross-validation error. Okay? We click on cross-validation error to yield this graph.
Okay, you see, your third neighbor, your 9th and 10th neighbor, give a good validation. Okay? They are very close or familiar with what Priera is. How do you improve your cross-validation? Please select your important predictor again. Okay? So that means it's not always good. You have many friends. You must have a close and familiar good friend who has validation about you very better. Now you all of the predictor. How many kids or how many pets you have, how many dog or cat you have. Now that's not important information. Okay? The third, the 9th and 10th give you a good cross validation. Your validation not approach 70%. So maybe you can select fewer and more important predictor. Your validation will be higher. Okay? Too many noisy. Your independent predictor select not good. Okay? So not always have use many predictor. Your accuracy, your classification will be better. No, not this way. Okay? Something like our social relationship. Not every party you attend there is good. Okay? It's insufficient, the social relation. Just kick it out. Delete it. Okay? Just attend the important party. Keep a good quality social relation. Okay? Somebody is not enough for you to exchange something, right?